This is netstack.fm, your weekly podcast about networking, Rust, and everything in between. You are listening to episode 17, recorded on the 21st of November 2025, where Glenn has a conversation with Larry Masinter about the early history of the web and the revival of the Interlisp project.
Welcome to another week of netstack.fm. Today our guest is Larry Masinter. He's an early internet pioneer and ACM fellow. After attending the Stanford University, he became a principal scientist of Xerox artificial intelligence systems, and he's also the author or co-author of 26 of the Internet Engineering Task Force Requests for Comments or RFCs. In case you worked with any of the HTTP 1.1 or URI RFCs, you might have seen his name. He's a true legend, and I'm very happy that he's today with us. Despite the fact that he's in pension, he is still very active and is working very hard with plenty of other people to bring back the Interlisp system, about which he will tell us all about later as well. So welcome to our virtual studio, Larry.
Great, I'm happy to be here.
Maybe to get started, could you maybe tell a bit about, how did you get into software and computers, because it was still very early days in those days.
Right. I was an undergraduate at Rice University in Houston, Texas, and I was a math major. And I was thinking I was going to be a mathematician. And when I was growing up, I wanted to be a scientist. I tried to build a computer when I was in sixth grade. And then, of course, it didn't work. I didn't know that you could make relays out of electromagnets and nails. But that was my early interest. I read some books about artificial intelligence and perceptrons. And I thought that was pretty cool. Well, and it's taken, this is in the 50s. I was born in 1949. Mathematics really attracted me because it was the truth, that everything else was statistical and determined by experimentation and revisable, but math was the truth. But I learned some things about computers. I went to a summer science institute by the National Science Foundation in the U.S. Between my junior and senior years of high school. And I learned programming on a 1620 and a UNIVAC 1100 assembly language. And that was a lot of fun, and so I kept that up. And had a part-time job trying to teach computing at a business college. That was hopeless. But when I went to Rice, I was thinking that programming was a way to earn money, but that I kept up with the math and came out to Stanford to be in the math department. This is in 1970. But Vietnam came along, and the fear of getting involved in the war led me to apply for this status called conscious objector. So I did that, and we had to do 2 years of alternative service. But my alternative service was to work for the Stanford Medical Center for 2 years on a project called Dendril, which was set up to analyze unknown chemical compounds by their mass spectrograph. That was an interesting project, but it turned out to be a mathematical problem of how to generate all the graphs that satisfy the valence rules, given the molecular formula of how you find graphs without any duplicates. And that needed some group theory and graph theory. And so that was my first real programming job. I was working for Stanford in the joint project by the Stanford Medical Center and the Computer Science Department, led by Ed Feigenbaum and Carl Gerasi and Josh Lederberg, who was a Nobel laureate. and Carl Djerassi invented birth control. And Ed Feigenbaum was a leader in computer science. So when that was over, I switched to the degree program in computer science, and I stayed on as a grad student until about 1980, but I was really working at Xerox. When I was working on Dindrel, we were using BBN Lisp, and there were a lot of features that I had implemented for Lisp 360 at Stanford that hadn't weren't in Lisp, and I thought I was missing that. I learned Algol at Rice. And so combinatorial programming, and I took over the implementation of the structure generator from someone else, and that formed my interest in programming as a kind of domain where artificial intelligence would be useful. And I worked for Warren Titleman, who was the original founder of the Interlisp project. And I'll get into that later when I come back to what I've been doing lately, because I've been working for the last 4 or 5 years on revival of Interlisp as a historical artifact that runs on modern computers, and that you can experience what it was like in the early days of Xerox PARC.
Okay. That's very interesting. And I mean, I imagine in those kind of environments, it probably was quite intellectually driving. And if we zoom in on Xerox PARC, like it's a pretty magical place, and I don't really know. I think a lot of people from my generation sometimes wish that we could have worked in a place like that, because a lot of like really magic happened there, no?
Yes, it was very intellectually stimulating. I remember Feigenbaum got mad at me for saying that I thought the staff at Xerox PARC was more interesting than the faculty at Stanford.
Yeah, I can imagine. Was it actually like a big place? Like how much people work there at those kind of projects?
Maybe there were hundreds, maybe 100, not a lot. And then they did recruit top people. Although, I think my role was more as the technical leader. I inherited from Warren Titleman and the Interlisp project. And it was an infrastructure project to build something that other people could use for research. And so we had a lot of users around the world of Interlisp. And we worked on the Interlisp D, the window graphical user interface version of it. Anyway, I recommend people go to interlisp.org, to our website, where we've put a lot of material. But along the way, there was a standards effort called Common Lisp and the ANSI committee XVJ13 that I started to work on to come up with a common dialect of Lisp that all the different Lisp implementations could use, because the Department of Defense in the U.S. Was tired of funding people who wrote programs that were incompatible with the systems that other researchers in AI had. And so XVJ13 was founded to come up with a common Lisp language, and I became the kind of representative of the Interlisp side in the Lisp wars. And that was interesting. I wound up chairing the group called the Cleanup Committee. So there were committees on multilingual text and object-oriented programming and the error system, some big projects that needed to be handled in the Lisp environment. But then there were a lot of things that were small problems. And I invented the form you had to fill out to get a change to the language. And the methodology of saying you had to fill out this form, where the first part of the form is you describe what the problem was without reference to your solution. And the second part is you describe what your proposed solution is without arguing for it. And then you had to write costs to implementers, costs to users, etc. before you got into testimonials and history of the feature or whatever. And that was very successful in getting people who were arguing get them to agree that the form was filled out. If they could agree on the form, then you could say, well, there are some places where you trade off the cost to implementers and the cost to users, and you have to make a choice. At least the nature of the choice and why people were making it was clear. Anyway, as I had worked on Lisp and the AI winter came along and the market for Lisp and Lisp machines and other things kind of died, and I had to switch at Xerox because I didn't go with the Lisp spin-out. I had to switch to something else. So at the time, Xerox was trying to reinvent itself as the document company as opposed to the copier company. And so we worked on some document servers, as in this whole client-server architecture for accessing data from disparate systems. And we had 3 or 4 different kinds of systems that were in use at PARC after the denouement of the Lisp machines. And they all had different file formats. And so what we defined was a document server was different from a file server in that the document in text and in PDF and in Word were all the same document, just in different formats, with some amount of the difference between the identity of the document and then the representation of the document. And this notion of separating the two became an essential part of HTTP, that you would request something, you would hand the server your request, and the server would give you a representation of the state of that resource. You never transferred resources over the network. You only transferred representations.
You mean like metadata? Kind of like how you would use like a HEAD request to just get some header spec to get information about the resource?
Well, you would say the client would present to the server a request. Give me the resource with this path and accept. And these accept headers about what representations you could deal with. And then the server would return you some representation. You asked for an image and you gave it text. So there was an interim project at the time at PARC called System 33. And System 33 was an essential part of what we were trying to bring into content negotiation. I thought underlie was the underpinnings of the HTTP distinction between resources and representations. Roy Fielding wrote this as part of his thesis, a model called REST, which was a good, more theoretical approach to what we were trying to do with files and file formats.
This was already like a network server, right?
Yes. System 33 was a network server, and it shared the protocol from, it had a kind of protocol similar to Gopher. Gopher was the inspiration for HTTP 0.9.
And by the way, like it's actually despite how of a fundamental of a protocol it is, like it's the first time somebody brings Gopher up on this podcast. Like maybe for the especially younger audience, could you maybe quickly explain a bit like what Gopher was and how it was working?
Well, Gopher was an outgrowth of the network instantiation of the common notion of a menu system, where the information resource had a bunch of menus, A, B, C, D, E, 10, 15, and you would select them and you would select what you were looking for. And maybe you could type in a query, and you would get back text or a PDF. Actually, this predated PDF. So it was a menu-based system, which you could turn into hypertext by adding all the stuff in between the links. So Gopher was a system for doing network access to information and for resources, but only through menus. And the invention of hypertext, which had been gone on independently, Tim brought that hypertext into Gopher. And I remember when I visited CERN sometime in, the early 80s, early 90s. No, I don't remember. They had a chart of the number of sites that were Gopher versus www. And they were working on increasing the acceptance of Gopher and of the Gopher community to the web. And what was critical at the time was that CERN decided to make the web open source, while Gopher was caught up in a plan by the University of Minnesota to start charging license fees for using Gopher. And that difference was instrumental in Gopher, that and several other things. So we worked hard on getting a Gopher URI scheme that could encapsulate all of the kinds of different ways you could request things that were Gopher, so that the web could include everything that the Gopher could do. And so that was important.
And did those URIs differ a lot with what we now know in HTTP?
Well, HTTP 0.9 was very much like Gopher. You open up a connection, you send the request, you get back a document, you close the connection. And the performance wasn't really important because this was the number of requests you would get would be one per document. So you would retrieve the document and close the connection. And you didn't want fast start or cache connections or anything else because there was no embedded objects. I think HTTP 0.9 open a connection, send the request, receive the results, and close it. That happened. How often would that happen? Once a few minutes.
Yeah, correct. And I even remember with HTTP 0.9 is that like there were a lot of headers not even there yet, like including I think content length. Sometimes you would just send a payload, and then because you close the connection anyway, like you wouldn't even send the content length because you would know when the connection is closed, that's when my payload ends.
That was important for doing services that are URLs. The first map server was done by Steve Putz. The map server for the web. And that had the feature, this was before we had forums, that you would just click on links as your user interface to modify what the map server was showing. That was an early paper in the web conference. To show that you could build a service with only using hypertext links without any other way to input data.
And that would mean that each time you want to like navigate in the map, it would need to make a new connection, fetch that part of the map and serve it to you.
Yes, right. Well, the only data it had was the coastline data from the internet resource of all the coastlines of the world. So that was the only navigation you could do.
But I imagine it's still very exciting if you were seeing it at the time.
Right, yes.
And then to go back a bit to the fact you were trying to come up with like a URI scheme for like Gopher and connecting it to HTTP. But does that mean that at that point we already had things like hostname and path and those kind of things?
No, hostname was added later. Hostname came from the need of server vendors, service providers, to have multiple host names, all served by one computer.
Right. Yeah, because I imagine in the past it was just a server is one server, really. So you really identified already because you connect to it over TCP with the correct IP address. So I suppose you already know that's the server I'm connecting to, and at that point you can only just use the pot, I guess.
Right. Yeah.
And query parameters, was that a thing or also not yet?
I forget when query parameters came in. Might have been part
Okay.
of the original design. The query parameters came in with forms.
All right. Makes
Right.
sense.
HTTP 09 and the early web didn't have forms and didn't have embedded objects. At the time, I imagined people use a format like PDF, where a compound document format. That's what it was. Apple had one, and I think they called it Minto.
Which means that it sends you this kind of document and you fill it in and then you like upload it again. Is that what you're talking about, or?
No, I mean, for one of the differences between HTTP and Gopher was that HTTP was optimized for what we had to add when we went from HTTP 1.0 to HTTP 1.1 was the performance enhancement of sharing a connection for multiple requests, pipelining, because you didn't want the TCP slow start to dominate your performance. Anyway, getting ahead of myself. So I got into the web standards world because working on System 33, I was interested in finding other research ideas for how to create interoperability between workstations with different kinds of capabilities for displaying files in different formats. And the web was interesting enough. I started going to the organizational meetings around HTTP, around the web. And I invited Tim Berners-Lee to come visit at PARC, and he spent a couple of months there. And at the time, Hypertext, PARC had an active program in Hypertext called Note Cards. Note Cards is now part of the Interlisp revival that one of the original developers of Note Cards, Frank Alaz, has been part of our Interlisp project. And they were looking for someone to chair the working groups, originally the URI working group, and then later on the HTTP working group. And I had experience with standards. And a standard for a language is kind of like a standard for a protocol. And they're both languages for expressing interfaces between different objects. So when I talk about protocol, I want to include the language Lisp or the language Algol or the language Fortran or language Rust as just more kinds of interfaces. And the standard for an interface, if you want to make a change to it, there are really three things that surround the language that people speak. There's the specification, there's a written description of what the language is. There are implementations, things that take one or two or three, whatever it is that you're talking about. Each of them, they're implementations of producers and consumers of the interface for a bilateral interface. And then there are test suites that test whether or not the implementation matches the specification. And in the end, what you care about is changing the language itself, but you can't really do that. You have to either change the specification, the implementations, or the test suites to surround the language and change it along the way. And language specifications are much more complicated than implementation specifications. Although some implementations, some languages are specified by a virtual implementation. So you take Java, and Java is specified by the documentation for its virtual machine, at least some parts of it. So that's interesting. I think underlying this, there's some theory of documents and an algebra of describing how these things interact. And I spent some time on the W3C technical architecture group, and writing up, but I didn't really finish.
Yeah, I suppose. I mean, it gets very abstract, and I imagine it's easy to lose your mind on.
Well, so around the time of the pandemic, I was looking for some project. I retired from Xerox kind of on disability. I had Parkinson's and had it for a large number of years. I was first diagnosed in 2004. But after several years of not coping all that well, I had this procedure they call deep brain stimulation, where they insert some electrodes in your brain and to an embedded controller in my chest, which send signals that interfere with the Parkinson's tremors and the basal ganglia in some way that I don't really understand. But it gave me a new ability to focus. And I was looking for some project to take over my desire to contribute. And my former colleagues from Xerox, two of them, Ron Kaplan and Nick Briggs, were working on getting Interlisp to run again on modern hardware and modern OSs. That was my third attempt at a retirement project. I thought that I would do something that would help other Parkinson's patients, but I didn't make a lot of progress on that. And then when COVID came along, I thought maybe I could build a website to help people learn how to do things online, because I didn't think the pandemic would ever be over. But people discovered that on their own in a variety of ways. And so Revival of Interlisp became my main project. And now we've been doing it for 5 years. There's about maybe 15 contributors to the open source project. Yeah, it's on interlisp.org. You go to http://interlisp.org, and that should give you access to everything. There's a new primer that we've been funding some students at University of Alberta to help out, and we accept donations, of course.
Very cool. I mean, it even seems to include note cards and everything.
Yeah, it has note cards, has rooms, has loops. We have a lot of graphics packages. We have people who are using Medley Interlisp to enter into the game jam. Can you build a new game based on Interlisp? Retro-looking graphics.
Yeah, I mean, I'm a big fan of that. Like, originally, I come from the game industry, and yeah, it's very nice to work on older systems. They are a lot more easier to grasp, and especially also the hardware. Like, if you want to understand something like one of the older processors, like the ones in a Game Boy or like even older ones, I mean, they're relatively easy to understand. But if you compare it to like a modern CPU or something, it's an entire, I don't know, like a very, very big book or several books just to encompass the instructions, let alone all the details. So simpler times is nice to develop for.
Well, the implementation was based on the original implementation in Xerox PARC for all three of maybe 4 different languages we supported. And depending on the group, there was the Lisp group, there was a Smalltalk group, and there was a Cedar group, Mesa. And there was a lot of friendly coopetition that you see something in one of the other systems and you wanted it in yours, and a lot of cross-fertilization of ideas.
Yeah, I mean, if you look at these systems like Smalltalk and Interlisp, I always feel there is like something lost there. Now we didn't like recover again, like capabilities that they had that we are still missing today in like what you would call modern languages.
Yes. Well, the ability mainly, I think, in Lisp is to, at an error, rewind the stack and change the code and keep on running. Compile, load, execute to speed up the turnaround time to fix a bug and keep on going.
So I guess the first part of the project was to get it working on modern systems. Is it still like a big road ahead of you?
Well, no, the Interlisp project was originally at Xerox and was spun out into a separate company called Invos, and then that became that closed down, and there was another company started by John Sobalski called Venue, and he had the rights to create derivative works, and he passed away. And then the system was kind of in limbo for a decade or two, and until the era of the IPR rights to create derivative works and to distribute them, he gave to us. That's why we were able to make it open source. But that system included, it had already been ported to some workstations. And then we got it to run on a Mac. And so it was already kind of halfway, or more than halfway ported. But it was written in Kernighan and Plowger C. So there's a virtual instruction set. And then you compile your list, which I like with Emacs list these days, which came after Medley Interlisp, was that you compile the bytecodes. The bytecodes are an abstract Lisp instruction set. And so originally it was designed for very compact programs when memory was rare and a lot more expensive than CPU. But it has the advantage of also portability because most of the system is written in Lisp and only the very low level, the lowest level of abstraction is implemented in C by interpreting the bytecoded instruction set.
That's nice. I mean, that I can understand why that's makes your life a lot easier because that's the only part you would have to port, I imagine.
Yeah, well, in the end, it turns out some things are, and we don't want to rely on our common Lisp implementation because it's so lacking, and so we go out to the host operating system to do some operations like open up a web page or convert a file from PostScript to PDF. So some of these things still require that. We know all of the people on the project are volunteers. So, and most people don't work full time when they're retired.
Yeah, I mean, if it's a passion, I suppose you find time for it, but at the same time, I guess
Yeah,
life also moves on.
right. Well, we meet twice a week, talk about
That
implement.
yeah, that's quite a lot.
Well, not everyone who contributes it comes to the meetings, and mainly old timers and a few students, and we have a few people who are in between jobs or otherwise looking for some way to amuse themselves. What else can I tell you?
You can tell me a lot. For example, you can tell me how in 1998 you invented the Hypertext coffee pot control protocol, or HTCPCP.
There's a tradition in the IETF of April 1st RFCs. The IETF produces a series of documents called RFCs, which originally stood for requests for comments. But it was really kind of late in the process to be asking just for comments. Request for errata, probably. But not every RFC is a standard. And the RFCs have RFC numbers. The goal is the RFCs never change. If you want to make a change, you need to the language, you need to create a new version of the specification, or at least updates. So one RFC can either obsolete or update another RFC. But not all RFCs are standards. And to make this point, I think, introduced the notion of an April 1st RFC, which you can tell by the date of the RFC is always April 1st of the year. And it's the only ones that have the day of the month in them explicitly. So an April RFC is not an April 1st RFC. So there's some famous RFCs. There's the HTCP over carrier pigeon, over avian carriers, where they describe how to, there had been a large series of documents about how to do TCP over different transmission media mechanisms. So HTTP over cable television and TCP over, I said HTTP, but I meant TCP. TCP over modems and different kinds of ways of carrying TCP over transports. And avian carriers was how to use carrier pigeons to do TCP between different using birds.
And did they also try it, or was just purely theoretical?
No, some people did this. They reported on their success at doing TCP over carrier pigeons. And but my favorite line in that RFC is the bandwidth is proportional to the leg length, the width of the band around the carrier pigeon's foot.
Yeah,
It's proportional.
that's a quote. Yeah, I just wonder, like, is it just like is it then something that you just think like, okay, this year I want to be the one writing a 1st of April joke, or do they come to someone in the community and say like, maybe this year you can write one? I know how does that come?
I'm not entirely sure, but I believe the RFC editor originally was John Postel was the RFC editor and the keeper of the April 1st queue. But now I'm not sure. I think it's still the RFC editor or the editor's office or something. But at the time, there were a lot of proposals to use HTTP as a substrate for implementing something that wasn't web access. So the Internet Printing Protocol, IPP, wanted to use HTTP, and I was on this committee, and I thought, why do they want to use HTTP? And I never got a good answer. You know, it wasn't necessarily that it was adapted for it. It was HTTP is everywhere, so it must be good. And it seemed to me. So I wrote a little document trying to explain HTCPCP. It's somewhere on my website. My idea is that the April 1st RFCs serve as a instructive way of reductio ad absurdum. You take something and you reduce it to its essential into some contradiction or bad design or something. So my idea with HTCP was taking all the ways that you could extend HTTP to do something and misusing them. So I wanted a new MIME type and a new method, the brew method, which is equivalent to post. There had been a long debate in the IPP group over whether or not to introduce a new method. And there are no guidelines for any of these extension mechanisms. And
that means you can never cache your brew, as it's similar to post, you see.
yes. And the new URI scheme using Unicode, hex encoded, UTF-8 encoded Unicode, and for coffee spelled in different languages with an errata because I got the Japanese wrong.
Fantastic. I mean, not fantastic or wrong, but it's very cool that you still make an errata for it.
And the error codes, there are a lot of debates over whether or not what kind of error code you should use. If you wanted to be more fine-grained than a 401 or 402 or 404, and there's no rationale given for when to allocate a new error code. So I invented 418, I'm a teapot. Because of course it makes no sense to have HTCPCP request to a coffee pot for it to return that it's not really a coffee pot. Yeah,
And yet now this this code lives in pretty much every HTTP implementation out there.
right. Yeah, well, people got by the I'm a little teapot, short and spout. Tip me over and pour me out. There's several other things in there about firewalls and a bad security considerations section.
But then later you also co-authored an RFC around like the mail to URL scheme. But that's just about the URL, right? That's not to do with HTTP.
Yeah. No, it's just about the URL. There's an internet draft that is not an RFC, but that I like, and every once in a while I'm tempted to bring it forward, but haven't found anyone who would want to co-sponsor it. But it's about two URI schemes called DURI and TDB for using dates. And there's a problem that whenever you give a reference to the URI or URL, it's ambiguous about what you're really trying to refer to. And you say, this URL is in English. He's talking about just the resource that you're pointing to, the resource with all of its embedded objects, resource in the whole website, or the resource that is as it existed a minute ago, right now at this instant, or the resource over time. And the TDB URL was supposed to give you a way of saying that you could have a URL for anything. How many URLs are there? How many resources are there? Well, there's infinitely many. Are they countably many or infinitely many? Because countably is less. There are numbers that are not countable. Anyway, TDB stands for thing described by with a date. And you say, well, I mean the thing as of that date, no reference to the future stream of possible values. If you really want to come up with a formal definition, theoretical definition of what a URI is that it represents, that's a hard road for philosophers.
Yeah, I mean, I feel it has such an ambiguous use because I cannot even count how many, at least by now, how many protocols like use the URI and where they are similar, where they are not. And then, I mean, including also some RFCs of yours because you also are, I think, the co-author of the URL scheme to represent like data. I think base64 encoded, and even that is like called the URL, but like that looks nowhere near what most people would think of is a URL.
Yeah, the data URL reminded me of when I was learning assembly language of the UNIVAC 1100 back in my high school days. And so they had the thing called immediate address. You'd have an address, which wasn't really an address. It was just the number itself.
Would it be like just a random number, sequential number, or more like a hash?
So there was a flag in the word. So you pull up a word and you say, I want to read the word. You have something that takes a pointer. But you don't want to give it a pointer to somewhere where you store the data. You just want to give it the data itself. There were indirect addresses, which were, you would go and open the thing and it would say, I'm an indirect, and I'm really over there instead. And that's like with HTTP, and you get a moved, you say where it is, and it follows the link. But we didn't have immediate addresses, and so it seemed to solve some problems for people. The data URL has really grown in use now that they've figured out that the security context is the same as the parent that gave you the URL in the first place.
I mean, yeah. I'm not sure how much use there is today, but the place where I see it mostly is when people use it for like embedding images and stuff.
Right. Yeah, that needed more work. And they have the only RFC that has a picture of the author. And the data URL RFC is an example, which is a very low resolution image of me when my beard was dark instead of white.
Look at that. A little I never like even considered like opening the or like decoding the or like I don't know, embedding it in HTML and checking what's underneath the data. Like,
Oh, you have to have fun.
yeah, I mean that's why we do it, right? I mean, and that's all. I mean, yeah, I mean, how could you keep learning on something and work on your craft and keep exploring if it's not because you enjoy it? Like you just wouldn't, and neither would you keep exploring and trying to bend your mind because I mean, you were probably like, yeah, you tell me like with how I sometimes experience it is like, and those are also often my more happier moments is when I try to figure something out and I feel like my brain is really melting. And it can sometimes just take hours or days or weeks and you try to iterate and eventually you come up with solutions and sometimes in steps, sometimes immediately, I don't know. And it's those things, those epiphanies, like you feel like, okay, wow. Like I don't know, everything becomes so clear and I guess it's those kind of like sensations that you keep trying to rush, I guess, I don't know.
The eureka moment.
Yeah, and of course, sometimes it's a wow moment. Sometimes it's just I don't know, like more like a stretch or a series of moments. But yeah, that kind of feeling. And how come these things? Like okay, for example, if we take for example something like the data URL scheme, what was a specific need or purpose that, or was it just because for fun, or was there also like an actual like yeah we are actually having a problem here and this was our way to solve that.
Yeah, I wish I could remember, but I don't. And there was someone who had a problem that this came to mind as a possible solution.
And then, for example, if we if we look at something like forum-based file upload in HTML, because as
Yes,
far as I know, you also worked on that, right?
yes. That was a problem that someone at Xerox had, and they wanted to upload a file to a web server that was a printer, and they didn't have a way of doing that. And it seemed to me that we could do better than just adding an upload command. There was a lot of problems with form submission, and forms didn't have a way of specifying the server couldn't tell the client what fields it wanted or what MIME type it wanted them in, or the content negotiation was only one way, and there was no way to label the content that you got back as to where metadata was. So I was trying to generalize the solution. I think the modern HTML includes different mechanisms for uploading files, though, that were based more in the implementation. The politics of the web standards was, as most politics are, was really kind of ugly.
And that's mostly because of the commercial partners or also among like researchers?
No, it was mainly the what working group. Depending on who you talk to, they wanted control, or they were trying to manage their implementations without the interference. No, in the IETF, there's no membership. There's no in-group, the decision mechanism is rough consensus, which means that no one person can or company can hold you back from doing something. But sometimes that's rougher than others. And there is a philosophical difference about how the specification should or shouldn't accommodate describing what should happen in a situation where other implementations would say it's an error. So the URI spec is still under some contention. There's a working group version of the URL spec, and there's an IETF version of the URI spec. And this difference in name, talking about the same thing with two different names and two different specifications, is frustrating to a lot of people.
I mean, I find it very confusing, to be honest. Like,
Yeah.
because they are, I mean, so also the context is that I also am the developer and maintainer of like a network, like framework or set of libraries. And
Right.
so then at times I'm trying to maybe, I don't know, find common abstraction points between all these different URLs or URIs or this or that. And I don't know, there are so many little details but yeah, as you say, even just the name. And actually, I think even if I recall correctly, I think you have an RFC where you even explain a bit around like URI, URL,
Right.
URN even, I think.
Yeah.
And yeah, I don't know, like, but also it's just surprising how much stuff uses a URL. And they do often all look nowadays where they have like a scheme and a host name and a path and a query. Like, there are plenty of those, but yeah, that's not all it is, I guess.
I don't know what to do about the situation. I was hoping that when the original disputants retired or went on to another job, maybe some more rational people could come in and satisfy this conundrum. But I'm not sure. I don't think I have much to contribute to it anymore.
Yeah. Yeah, too bad. Because you were a very I mean, you were there, you know. That I
Uh,
guess my concern a bit, like, if we wait 10, 20 years more, I don't know, like how in the UK, I mean, when the people found the ruins of the Romans and they didn't even know what it was about. They thought it was like made by giants. And I have a feeling we also want to look at these RFCs or like at these old mailing forums or mailing groups and I have no idea what it was about. And then, yeah, a lot of context will be lost.
well, my consolation is that the stuff we have works reasonably well. So maybe the differences don't matter.
Yeah, I guess so.
Uh, that if there was really a serious problem, then people would jump in to solve it.
Yeah. I mean, they do work very well. I suppose the issue is basically that, yeah, I guess a URI can just be many things. Maybe it was a bit silly to call them all like a URI or a URL or I don't know, because they can look so different.
We invented the name change from URL to URI with the idea of carving off the URNs. And I think that didn't really solve any problem for anyone.
No, not
You know,
particular.
that was something I held up until I gave in.
And then at some point, I think you also worked on RFC, which is like RFC 2732, or I don't know how you pronounce these things, 2732, where it's about like formatting of literal IPv6 addresses in URLs. Like, I
Yeah,
wonder what is the use there. Like, I mean, because yeah, I don't know. Like, you wouldn't ever remember those kind of addresses, right? They're especially
yeah.
IPv6 and IPv4 address. I can sometimes remember, but an IPv6, I never can remember.
That was forced on us by the IPv6 committee. it didn't really fit into the syntax, and they should have fixed it before. But a little bit like the internationalization of domain names. And there's a DNS to ASCII transformation in the DNS protocols that is not the same as the way that you write a DNS name, a Unicode DNS name in a URL. And I remember going to the Internationalization of Domain Names Committee and asking them to please add to their scope the internationalization of URLs. And they said, no, that was scope creep. They wouldn't take on the problem.
Is that something that you would think is like a good idea? That you internationalize like URLs? Because it seems to me like it would be, I don't know. I mean, like origin, I mean, for example, if I look at it, the problem of things like phishing or scams, I would feel like once you can have like full Unicode URLs, like, I don't know, like you could have so much potential to confuse people of going to some wrong website.
Yeah, and it's absolutely there is a service provider that will sell you a .red heart domain. So if you want to be Larry dot and then a red heart emoji, so you can get emoji domain names, and many web clients will be able to access them.
Seems a bit, unnecessary. I don't know.
Well, people adapt technology to their own uses. And I worked on this problem for a while, and before I gave up on how to tell whether or not if you give a URL, how many people will be in your target audience will be able to take that URL and apply it and get the right answer. And then if you transcribe, if you go through a protocol that goes through a person reading the URL on the side of a bus and then being able to type it in and get the right resource, you can say, well, how many people can read that? And if you can emit the URL and it doesn't pass through the human reading and transcribing and using, then it's not a very good URL. So don't make those up. Don't pass them around if they're not. And then it's not up to the protocol to decide in advance which things will or won't work. So my email address is lmm@acm.org. And every once in a while I get people who treat the initial L as a capital I.
Yeah, and that's like still a simple example. So
Yeah.
I mean, yeah, once you have Unicode, that's
They're just more examples of ambiguities like that.
yeah. Well, okay, and then I feel like definitely a big one you also worked on besides URIs and a lot around data and Interlisp is also the fact that you contributed to the HTTP 1.1 spec. I mean the original one,
Yes.
which was quite I don't know. That definitely was a turning point, I feel, of HTTP, where it went from its origins to, I feel it's kind of like the portal between the origins and where we are now heading with HTTP, well, HTTP 2 and then later HTTP 3. Like, definitely, I feel like a lot of that started here, like where they had the concepts they want to solve, but I guess maybe not at the time having the tools to do so.
We were trying not to be inventive as much more as selection. That there was a problem, different people could come up with different solutions, and they all couldn't coexist, had to choose. And we were not trying to avoid trying to invent new things.
So all these, they were like mostly out there in the wild, you see, like all those different headers and concepts, but maybe like in incompatible ways.
Yeah. Yeah, the HTTP one spec was not intended to be a reinvention. Just the ambiguities that people felt. And so current implementations were really important. I never felt like we could make the kind of changes. Remember, when the HTTP BIS came up under Mark Nottingham, I went and gave a talk at their working group meeting, saying, we couldn't change this. We couldn't change the referrer field to fix the misspelling. We couldn't make that change.
Yeah, it's still in there. It's kind of weird, right? Because I mean, you could, I mean, you could come up with a solution where you say like, okay, you have like a long period, like even if it's 20 years, where you use both, like you accept both headers, like you have like a referrer and the correct spelling, and then I imagine it would probably be safe after 3 decades to phase out the, I don't know, like the original one of it. Seems like never
The only
happened.
time the change was mandated was the addition of the host header. That was the only thing that wasn't optional.
But like among, for example, some things in even in those original specs, I never see in the wild. For example, the trace header, like I never, oh no, sorry, not header, the trace method, like I never see it being used.
Yeah.
But then again, I feel in general people don't really use methods a lot. Like that's kind of like for example, like one thing, the one reason I started with this podcast was because I want to educate people around network protocols. And so, for example, a common thing, and HTTP is an example of that, because I feel most developers don't even know, even if we just talk about HTTP 1.1, like how it works or what it has, like all these methods, all these different status codes. Because, like, I mean, if you like some protocols built on top of HTTP or just always returning 200 OKs, even if it's like an error, and then they will put the error in the payload or something or whatever, which is very confusing,
Yeah.
especially for proxies. And then, or like, let's say I visit the website, and so for example, I'm from Belgium, so we speak like 3 languages here, at least the official one, but of course there are plenty other ones. So there are also people living here which might speak a language which is not official. And yet, because a lot of servers do it like geo IP based, they will like serve you, I don't know, French, because maybe your IP address looks like it's in Brussels or in the
Right.
French side of Belgium. And that's a very frustrating experience, because like you might not even find where to switch the language, because maybe it's not a language you're familiar with, and so you're trying to look
Yeah.
around, like where can I switch the language. And so I don't know, like I find it a shame, because like we keep working on new protocols, but I feel like we are not even properly using the original ones yet. I mean, not original, but still, like these are. I mean, for example, HTTP 1.1 is from 1999, so I would have hoped that there is plenty of time to learn about it by now. How like it works, all these different status codes and methods and headers.
I go back to the tripod implementations, specifications, and test suites. And what working group has really taken on the test suites define what the language is, and the specification is also ran.
Yeah, I mean, I feel the specification is fine, the language is fine, the test suite is fine. It's more like people don't seem to be aware of it.
Right? Yeah. Well, that's down to the implementation. It seemed to me that there was a difference between the difference also has to do with how many implementations are there. The emitters of HTTP, HTML, there are millions.
Yeah, for sure.
And while HTML interpreters is really a decreasing number of them, but with Edge turning into Chrome, and we're left with Safari and Chrome
Well, you still have Firefox, of course.
and Firefox.
And then like you have like what is it called, Ladybird? Is that the new one on the block?
Yeah, but always a handful.
Yeah, for sure. Well, but I mean, yeah, yeah, for sure. It's not an easy one, of course, to do, but but you do want it, of course. But yeah, there's so many protocols to be implemented, and especially I don't know, they keep pushing out new standards, because then you're not only talking about network protocols, but you're also talking about web APIs and this and
Right.
that. And like I feel like every year we have like, I don't know, maybe 10 or 20 more of these. So it starts to add up, which sometimes I do feel like, I don't know,
Yeah.
maybe we should just like pause a bit. Like, I'm not sure we need so many of them. Like it's,
Well, everyone with standards, there's a value in having things work the same. And there's a value in having them work the same as long as it's my way.
yeah, exactly. So I guess it's also like it also helps if you're the first one, I guess, to do it, because you get to define your way, I guess.
Right.
If you look back at on all this, and how HTTP is used now, and or how URIs are used, like I don't know how you feel about it.
I thought I did some good work. And but I got away from my being able to be hands-on. And so I'm happy to be back in the world of Lisp and an implementation where I'm the technical lead, kind of, and I can hack away.
It's amazing, like and nowadays, how do you develop? Like, what kind of system do you develop on? What kind of editor? What kind of, I don't know, terminal? Those kind of things.
The Interlisp was an operating system.
And
It
that's
was the
also what
whole
you
system.
develop on.
And you develop in the Interlisp environment using Lisp. I assume the emulator is pretty much done. Have a good implementation. It uses X or SCF for display, and you get a window, and it's black and white and pixelated, and you develop in the whole thing. The nice thing is that it runs 1,000 times faster than it did 20 years ago.
I mean, in a way, it's nice, but also I can imagine it can also cause issues.
No, it had a way of slowing down. Some of the graphics demos had to be slowed down.
I read that Interlisp was using another kind of encoding, which was like from Xerox, and now you switch it to Unicode. Like, what
Well,
was
yeah,
what was the original then?
it's called the Xerox Character Code Standard. It was one of the original contributors to the Unicode. The Unicode was based on XCCS and some other work from Apple, pretty much. ISO 646. Joe Becker did the original Xerox Japanese typing system. And he did his prototype work in Lisp. And we switched to Unicode as an external format, but inside the strings are all represented in strings of 16-bit characters.
That's kind of like UTF-16 then.
Well, except with different character codes.
Mm.
So we were working on revising our fonts to use more modern fonts. Unicode support is a big deal. Better fonts is a big deal. We're working on reducing the overhead of getting into it. So if you go to online.interlisp.org, you get you can log in over the web. It opens up a VNC connection to a Docker container. It runs Interlisp in a sandbox for you. And if you log in and give us a username and password, we'll keep your data for at least for 6 months.
Yeah, I mean, it seems I can even run as a guest just to try it out.
Yeah, you want to log in the guest and you don't get a persistent file system.
That's very cool. I feel I could spend some months in here, locked up in this virtual
Yeah.
environment.
Well, we have full implementation of PUP and XNS prior to the TCP introduction, because the Xerox protocols were far more advanced than the internet protocols.
But you mentioned POP. I mean, I only know that in the context of mail protocols. That's what you're talking about?
No, PUP was a whole file access, complete protocol stack: printing, filing, inter-device communication, and a remote eval server. The loops system for the Lisp object-oriented programming system had a game that they were calling Truckin'. And there's a way that you can run Truckin' on multiple D machines. This is in the early 80s. And this sequence packet protocol and courier remote procedure call, all in full implementations. So I'd like to put together a demo using older protocols of networking in the Lisp world.
And do you think there would be like, I don't know, benefit or use of porting some of these to I don't know, implementations in modern languages and make use of it? Like, do you think it unlocks potential that we wouldn't have now, and or these kind of things that you would build on top of TCP, or where would they be?
I'm thinking more of historical reenactment. If you do a historical reenactment of a famous battle, more for the understanding of how the internet really began. That's what we're doing with a lot of our demos. We're trying to get into the computer museum support business.
Is
I
that the
mean,
one in the Bay Area, or which one was it?
well, we have an exhibit of Medley running at the Interim Computer Museum, which is a follow-on from Paul Allen's Living Computer Museum, which closed. And what I'm hoping is that we can make some demos where you click on the URL and it brings you into running Medley online with the demo loaded and let you explore from there. It's a kind of demo mode. That's one thing that our project, the Interlisp project, the Medley Interlisp project, is working on, is demo mode.
I just looked it up, so seems I wasn't too far off the ball. Like because you said pop, right? And I was
Yeah,
thinking it was around mailing, but that's exactly what it's about, no? Like that effect where I mean, it's basically the protocol of one of the protocols used to between mail clients and servers, no? For
yeah, it's
sets.
certainly this one application for sure.
But you're saying there's a lot more of it. I know there's fax and stuff and those kind of things. Is that what you're referring to?
There's a pub file server access. So we had a file server called the Interim File Server IFS, and there were a bunch of file servers. The Computer History Museum has the backups from PARC of a lot of systems that were given as a gift from Xerox.
Very nice.
And I'd like to revive some of those systems because there were early systems for collaborative work. The Collab had a lab where people could share screens and communicate and work independently. Decades before Google Docs. I didn't have a lot of aspiration of this stuff being useful as is, but as a source of ideas of things that have already been explored as prior art for patents, as a way of giving people another perspective on how things don't have to be necessarily the same.
True. And is there a set of, I don't know, criteria or items that you would say like if we achieve this and this and this with the Interlisp revival project, then I would call it success? Or is it just for you all have fun, you keep doing what you can do, and that's it?
My goal is to reach escape velocity, I tell people. Escape velocity is the system can be maintained without any of the original developers. So when there's enough people working on because we didn't start with a clean release. We started with the 1990s version of Interlisp, where they had heard John Sabowski had increased the address space by a factor of 16, 4 bits. It was originally a 24-bit address space. Now it's a 28-bit address space. And several other improvements, including the Common Lisp standard implementation, which had changed. And so we have some major problems. We have a GitHub, it's all on GitHub under the Interlisp group. If you look at the half a dozen repos. So I'm trying to run the project as if it was IETF, decisions by rough consensus, and everything open. So the meeting notes, groups are all available for anyone who wants to see. I'm hoping the website is a good introduction. I'd recommend people especially look at the bibliography, which is new. We have a collection of papers and reports about Interlisp and also about systems built in it, if they discuss Interlisp.
Yeah, I mean, there is a lot of reading material on there. You could spend an eternity reading all that.
Well, tell your friends.
We can all take a part and we can split the work.
Well, things that you find interesting.
Yeah. I mean, personally, I always found these languages very interesting. I don't think I've done too much with Lisp itself, but I've done a lot of work around the scheme, which is, as far as I know, derived from Lisp.
It's derived from, but it's we turned Interlisp into a system implementation language. So you could read and write packets. And if it was the whole operating system had to be done in Lisp.
Well, that's super powerful because, yeah, I mean, that means you can basically modify on the fly everything.
Yes.
But at the same time, I have a hard time envisioning that you could ever do that. Like if you want to have a complete system, it's not intuitive to me that you could ever do that very efficient.
Well, I have a new way of thinking about efficiency, which is not in terms of percentages, but rather in terms of years of Moore's law. And an efficient language is one, these days, is one where computation can be done in parallel.
Yeah, that's true. If I was still like younger and before I had a family and a couple of kids, I would have probably spent way too much of my time reading quite a lot of this. It's very nice.
And we're taking a different approach to software preservation. We're not trying to preserve. If you want an emulator of exactly what a D machine, the Xerox Lisp machines, felt like you could get one of those. We have them point out how to do that. But we're really trying to bring it to the point where it's usable for people who want to build something quickly.
Yeah, the way I like to contribute also to preservation is often to I don't know, re-implement old networking protocols and making sure people can keep connected to them. I mean, we talked about Gopher, for example, in the past, like in the start of the conversation, and I mean, it's still being used. Like, there are still plenty of Gopher servers, and like people sharing and interacting with each other via Gopher.
Yeah.
And I mean, I find it very exciting to implement these kind of protocols and make a client for it and have a server for it and be part of the network. And yeah, I mean, it would be same even for this, right? Like you, one aspect is the Interlisp, but you also have many like protocols there. Some unique to some are
Right.
unique to Xerox, but like it could also be cool for others to, I don't know, connect from the outside over those protocols to Interlisp systems.
The focus that we wanted to have was on connecting Interlisp to Star and the Gateway Access Protocol and the PDP-10 Lisp. There was some early work that I'd like to be able to demo. And then of remote eval and email. There was talk about an ARPANET reenactment of the, and that would be possible. What we're trying to do is encapsulate the XNS and PUB protocol packets inside, or currently inside HTTP. I'm sorry, inside TCP. There is one fellow who built an emulator he called Dodo for a D machine with flightless bird that is now extinct. The Dodo network encapsulates XNS inside TCP, but as a way of demonstrating or letting people play with these older protocols to see what it was like. So we were currently working with Professor Eric Kaltman at the University of Alberta, who has a group called Software History and Future Technology, and his broader research is around using emulations for software preservation. And it seemed like he was a good collaborator. And they have a lot of students who are in the library school or the digital humanities group that have been helping us with the primer and the bibliography and giving some talks about the project.
Very, very good. That's good. It's good to have those kind of collaborators.
Yeah, I figure we're not going to reach this escape velocity unless we have some younger participants.
Yeah, and I guess where to find them better than universities and students that are probably just as passionate and might. I mean, probably like me, where we often feel like we missed the boat there, or where we wanted to be there, and I guess this is kind of like their moment to, or their chance to, I don't know, live a bit in that time, like be it via
Right.
the preservation and helping to maintain it and evolve it. I guess it's as close as we can get to it, being born way
Right.
too late.
Well, the bibliography work really turned into its own project. I think we could extract that out of the Interlisp package, out of our website, and turn it into a general Hugo theme or some other kind of extension. Or if someone wants to build using Zotero, the citation database open source project, using that to gather the bibliography, gather the metadata, and then return that into static HTML pages.
Yeah, I mean, those kind of websites are always also very interesting. Like, and
Yeah,
there are surprisingly a lot of them around all kind of topics and science fields, but it's not always easy to find them.
right. And then when you find them, being able to search them. I'd like to look at the possibility of using some people who are interested in using AI to enhance the museum experience.
Yeah, I mean, I would think that within the United States there should be plenty of those kind of field people that are both knowledgeable enough and have interest, but I might be wrong.
Yeah. So anyway, Well, thank you.
Yeah, it was my pleasure. I wish you all the best. I hope that you will reach your escape velocity with the Interlisp project and that you may see it in good health.
All right, great, thank you.
netstack.fm is brought to you by Plavayo, building secure, open, and resilient infrastructure with Rust, protocols, and purpose. This show is also made possible by Rama, the open source networking framework. Plavayo offers service contracts and welcome sponsorships to keep building and supporting its ecosystem. The theme music of this podcast was composed by DJ Mailbox. If you enjoyed this episode, don't forget to subscribe on your favorite podcast platform and leave a 5-star review. It really helps others discover the show. Thanks for tuning in. We'll see you next time for the next handshake.